Okay, good morning, everyone. It's my pleasure to welcome you all to this open source cryptography track, where we will have three really interesting presentations. So let's get started with the first one. It's strategies for evaluating open source cryptography by Javed Samuel. He is the Vice President Crypto Service at NCC Group. Crypto Services here in the United States. So Javed, welcome. Okay, I will say the presentation is here. Is this one, right? Is that?
Yeah, this one, yeah. It doesn't have a full screen, no?
Yeah. Yes, okay.
Okay. Yeah. Good morning, everyone. Thank you for attending my talk here on open source cryptography strategies. Hope that everyone has enjoyed the conference so far and looking forward to discuss open source cryptography. In terms of myself, I'm Javed Samuel, and I lead a cryptography services practice where we focus on cryptographic audits of design and implementations. This includes a fair amount of open source cryptography libraries and products. So during this presentation, I'll discuss a few of those examples. So we'll just start off with why do we care about open source cryptography? I'm assuming that most of you here are because you think it's important. It's part of the reason we are all here today. Then we'll spend some time looking at areas that you should look into with specific focus on key management and protocol analysis. And afterwards spend a few minutes on some prior audits of open source cryptography projects, and wrap up with just some questions for all of you as you go about in deciding which open source crypto library to use or developers of open source cryptography. So let's start off with why open source cryptography. One of the key things to note is that we should be designing systems assuming that our adversary knows the entire system. They may have access to the code, and that way that we aren't relying on security via obscurity, on the fact that the attacker does not know some specific detail of our implementation. Open source cryptography provides several benefits, and that includes transparency. Anyone can view the source code to view the implementation. For various other use cases, the customization and cross-platform compatibility is extremely important and valuable. And you will find that a lot of open source cryptography libraries will be based off a particular standard, an RFC, or some other standard that the audience, the person evaluating it, can reference. And there is also a reduced licensing cost as compared to commercial cryptography, the commercial software. Even for builders or users of open source cryptography, our cryptography principles would remain the same. So that does not change in that we want to guarantee confidentiality, integrity, that you can't modify. You have the guarantees on the integrity of the data, authentication, you know who each participant is, non-repudiation, so that you can guarantee the sender and recipient, for example, digital sign-in of a message. And obviously, with most crypto systems, you need a good source of randomness. Now let's talk a bit about crypto reviews or strategies as we look at evaluating open source crypto libraries, or if you're responsible for the libraries, some of the questions to ask. And that's sort of what I want the base of this presentation to look at, some of those questions, and then we'll look at some examples in prior open source crypto audits. We will have a variety of crypto algorithms. We want to try to find out are any of them outdated, insecure. Do we have algorithms that NIST or have been deprecated for some time? Also, are there specific attacks that may apply in your context? So it's important when we evaluate or use in any library to make sure you understand your specific context and whether, based on how you are using it, whether this, whatever guarantees still apply, you need to make any adjustments to it. From a dependency standpoint, you'd want to verify that we aren't relying on dependencies that might be outdated or that may have been modified, or we've had attacks and fixes have been completed and are not in those dependencies. Many crypto libraries are not going to implement everything from scratch. So you would need to have a good understanding of what libraries are being used, and are you comfortable, are you okay with that library? So it's one thing to, when looking at a particular crypto application, to understand the full stack of what it is that you will have within your system. If you are going to call that crypto library via various APIs, you'll want to try to get an understanding of, is this API clear enough to use? Would your developers have sufficient documentation to be able to use this effectively? And that's where misuse resistance comes in and is important, in that if used incorrectly, you may have particular errors or subtle flaws that become hard for you to detect. You want to look at, while we would hope to have it implemented correctly all the time, we know that is not going to be possible. So how do you handle various error cases? From an authentication and authorization standpoint, trying to ensure that our authorization is appropriate for your use case, what you are going to be using it for. And the various means of authentication, do they align with your needs? Many crypto implementations or open source crypto libraries are going to be based off an existing RFC, academic paper, a governance standard. We would want to try to verify, are we implementing it as designed there, as presented? Do we have any difference from how the functions are being called, or have we made any modifications or deviations from the standard? Because if we made certain deviations, that may affect the guarantees that existed in the standard versus what is in the implementation. And importantly, we would need to verify any input data. While we would hope our users would always be using our application for the intended use case, you should not trust user data, and you should always ensure that this is going to be verified. Is your library doing this correctly, or is the library expecting you as the user to do that verification? From a secrets management standpoint, and I'll talk a bit about key management as well too, is verifying how that data is, secret data and sensitive data is stored. Do we clearly zeroize or delete it securely? And is that something that you, if you are integrating this library into your application, that you need to do? Getting a good understanding of who needs to do what is going to be really important. From a serialization, deserialization, and encoding and decoding, we want to ensure that this is appropriate for the use cases that you are going to be using it for. And do we have any circumstances where we have like improper normalization or encoding and decoding that's inappropriate for your use case? And that if you are building something for different than the English character set and using a library that supports something else, so you do want to keep that in mind here. Also, when we have values being concatenated, what do you have as a delimiter? Is it something that can come in a normal, in your environment for order data from the user? And how is that going to be handled? Remember, an attacker may be able to use any deficiency in your system to gain some advantage or to have different bypasses that affect the security guarantees you would like to provide. From a key management is going to be really important in any open source project or any project you're building, and trying to get an understanding of how those keys are managed, whether it's from a key generation, key storage, are they hard-coded, the type and strength, how those keys are, the hierarchy, like how they are generated and how they are derived. Do we have a strategy of what happens if the key is compromised? What do I then do? You don't want to find that out only after you've had an incident and you need to replace the keys that are being used in your system. That is likely to be too late to understand, like, what should you do in that case? How do we store identities? Are they mapped to the particular keys or not? Do we have ephemeral keys, and making sure that we do understand those are ephemeral keys in our key exchange? We want to try to make sure that for any like ambiguity of which keys that we should use, because that can lead to specific attacks, such as a duplicate signature key selection attack. And again, review our algorithms for when we're deriving keys, whether we look at things like do we have a salt, our iteration count, what memory hardness that exists here. From a protocol standpoint, I just want about like different things that we should look at when the evaluator looking at any crypto library or application. Like, how do they handle replay attacks? If I send the same message multiple times, how does your protocol handle this? Do you have any unauthenticated option in your handshake? Any parts that the user might use something less secure than you expect? So it might be that that's in the library, but in your use case, you don't want to provide that option. So making sure that you have guarantees that align with what your requirements are. From state management, looking carefully to see at all state transitions are as expected, and we don't have cases where we can skip a particular state or get to some invalid state that was not considered. Again, look at from a tampering perspective, assuming that you may have a man in the middle, in that case, what attacks are possible? And if someone, again, as we've spoken in the post-quantum workshop a lot about harvest and decrypt later, someone has captured that data from your system, from your application, are you vulnerable to offline attacks here? And are there any algorithmic complexity attacks that could be leveraged here? Some of our common attacks that we've seen in various audits and from various open source crypto libraries have included like insufficient randomness, that is inappropriate for what you would plan to use it for, your initialization vectors not being generated appropriately, or a lack of key rotation, like not having authenticated encryption, like encryption with integrity protection, or your chain of trust that's or broken and does not provide what guarantees that you want here. Now we'll switch gears and talk about some open source projects that we have looked at over the last year or so. All of the reports are public, and I have the URL at the bottom here. So if you do want to view the full report, feel free to do so. First one is auditable key directory that was done on behalf of Meta. And that was, they discussed our audit on a presentation at Real World Crypto earlier this year. In this library, what they were providing is the ability to map public keys to user accounts. And they were able to then provide that for efficient cryptographic validation to an auditor. And this library is open sourced and has been used by several other companies to build similar systems. So we've done reviews of other systems that have leveraged that library here. In terms of issues that were found during this particular audit, I wouldn't go through all of them in detail here. Just want to highlight a few points. One of the good things we see here is that Meta fixed all of the issues. And that's one thing that we can, that is great about open source cryptography. In assuming you have developer support, you're able to address issues and strengthen the library. So that way, when other developers use that, they have a more secure system. We have, in some of those issues there, cover the areas that I brought up and discussed earlier, whether it was having APIs that could have been improved and from like a misuse perspective. The first one that was regarding an invalid state transition. And we have orders that are going to be like from invalid, like insufficient input validation. So a range of different issues that were raised and importantly addressed. So that's sort of what we can get from understanding from open source cryptography. Someone leveraging that library could see the progress being made there were certain gaps, as I said, a number of the issues there, most of them were lower informational, and what is impressive is that they were all addressed, all had mitigations subsequently checked into the repository. Next one we want to look at is what we did on elliptic curve cryptography on behalf of Entropy Crypto, which covered big integer arithmetic, prime generation, and various Rust crypto crits. The source material for this case was an academic paper on the open source code. In this one, we had a variety of other issues, whether it's from validation standpoint, some more mathematical issues regarding timing attacks and side channels. And one of the things that we want to then see that some of the recommendations that we give for this report here, and also applicable in many open source projects, include the following here. We'd want to ensure we have sufficient documentation. And what's also important here is making sure that that's kept up to date. We have many projects where we have great documentation for version 1, but as new features are pushed in, the documentation becomes less and less substantial. We want to ensure that we have documentation that focuses on the use cases that you want to highlight, that you anticipate folks might leverage or use your implementation for. From a test coverage standpoint, a lot of times then folks might incorporate this code into their own code base. So ensuring that you have sufficient test coverage, they can leverage it to make sure that what they have integrated works appropriately. And the final one here is like leveraging from a standards perspective. One of the recommendations was to leverage FIPS 186.5 for their prime generation mode. And the final one, that example that I would talk about, was one we did on a threshold signature scheme for Frost, a flexible round optimization of threshold signatures on behalf of Zcash. And this one, the source material was a later draft of the Frost specification and implemented in Rust. Again, some of the recommendations on what you would like to see in open source crypto projects it comes down to, again, you are not going to be the only one using your code and using your library. So having well-implemented code with comments is really important. And in cases where it is implementing complex functionality, that's even more important because you want the folks that are using that code to be able to use it appropriately. A number of findings spoke about lack of input validation. And that was something that was highlighted, so that could have been strengthened and also applies in many other open source projects. The implementation also had a companion Frost book, like a documentation reference, which was really helpful. And some suggestions to it were to have more usage examples that more easily describe like how best this library should be used, and it will make it easier for developers that leverage this library to use it appropriately. And in some cases, being able to better publicize it in that document would be helpful. One thing that was valuable in that particular review was it included a list of security requirements. And one gap or improvement here would be when various things in the security requirements might be more implicit. So someone looking at this standard may not realize that this is a key check. It might be implicit in the description. And that could be something that could be easily missed by an implementer trying to follow the standard. Not because that they're unable to do it, but because it isn't clear enough that this check is explicitly needed or should be a definite. Now we've spoken a bit about from like why open source cryptography and some examples. There are challenges, and I'm sure we all know of open source projects that like may have been really good for a few years, and then we have limited support and resources available to keep it up to date. And that's something that we need the whole community to be involved in, to be able to have sufficient support, whether it's our large companies or various developers, being able to, it is an important part of our ecosystem. So we need that consistent support from the entire community here. There's also, and you may get that different view, where from a security perspective, because all the code is public and all the vulnerabilities when you have a pull request will be observable by your attacker, it may increase the risk of someone that's using an outdated version, because whatever is then fixed is now clearly available to an attacker. So in some cases, that may result in increased security concerns. So again, just wanted to I'll just quickly run through that various vulnerability classes that may exist, in like open source cryptography. We've spoken a lot about those already, and you saw some of that in various examples that we discussed earlier, whether it was the insufficient validation or insufficient crypto parameters from a key generation standpoint here. I just wanted to have different examples. All of those are examples that that have been reported in like a prior open source project or review that we have completed. So in the list of, I just wanted to highlight a variety of different types of flaws or different types of mistakes and improvements that could be done for open source cryptography. So finally, as we conclude here, I wanted to look through for a checklist in terms of what should you be looking for when trying to determine what library to use, or if you're building it, what are things that you should be trying to have in place here. We've heard a lot of talk, and we'll continue to hear about cryptographic agility as we move towards post-quantum algorithms. Wanting to be sure that we do have support for that you aren't tied in to whatever algorithm that's implemented today is what needs to remain for the entire duration of that library here. We'd want to pay close attention to key generation requirements. Like how are those generated appropriately? Do we have a sufficiently secure random number generator? And that is something that you want to verify that is being done appropriately in your proposed crypto library. Looking for information leaks, whether it's through error conditions, timing attacks, information that might prove valuable to an attacker. We'd want to validate any public keys and ensure that they actually appropriate or correct. And from signing, various areas that we should look into is whether we have sufficient randomness, whether replay protection, and so on. And finally, looking to see how compression is done, whether we are commingling attacker data, system data. We can have various compression-based attacks, looking to see how that's being done in your case here. And finally, as we all reflect on why open source cryptography is important, we will know that many of our applications and infrastructure are going to rely on open source cryptography. We are going to have it, and that's true today and will be true moving forward in the future as well. So it's all on us to look at ways to continue to improve the quality and security of those open source crypto libraries, because they are going to be used across a range of products and services. And that would help ensure that we meet our various security guarantees and requirements. And also, importantly, cryptography is going to be a moving field, so we would need to keep on updating those libraries. So something that is secure today may not be appropriate in 5, 10 years. So it's important to keep in mind that there is a lifetime here, that it isn't going to be something that you do it once and you never have to do it again. So happy to have any questions and answers there. If you are interested in learning about additional crypto vulnerabilities, my colleague Paul will be presenting in the crypto technology track tomorrow on unsafe cryptography and focusing on vulnerabilities in modern programming languages. Thank you for your time, then.
You mentioned that you validate whether an implementation of a cryptographic protocol faithfully follows the specification. So I wanted to understand better how that is done. Can you really establish the equivalence between a text document, which is a specification, and a piece of code, which is implementation, in light of the fact that you can manipulate arithmetic, you can transform arithmetics, a square minus b square is equal to a minus b times a plus b. You can do that, and code can also be transformed and reorganized. So how do you establish that equivalence? Is it manual? Are there tools and techniques?
Yeah, that's a very good question. So a lot of that would be from a manual perspective, looking to see that what you have defined in the specification. And we are taking assumption that the specification is well defined, it's clear, there are no ambiguities. And then, because a lot of times when we have such a review, the issue might not be with the code. It might be that the specification was ambiguous in that it does follow the specification, but it still leads to a vulnerability. Because of, that's why I brought up the Frost example, where there was some part of the specification which certain checks were defined as implicit, even if they needed to have been done directly. So you couldn't, but how you would go about doing so is looking for what's in your specification and mapping to your implementation. It also is important for all of us to be then parts of those specification bodies, providing comments and feedback, especially from the implementers, so that way we can have more well-defined specifications that are going to be more appropriate. Yeah.
Quick follow-up while I give the mic to the gentleman. That means it's manual code inspection, which also entails that you need to now find the code.
Yes.
So for your customer, you may not know where all the cryptographic code exists.
Yeah, that is a good point. Like you need to, if you have to map it, then you need to know where it is.
I might be wrong here, but I think NCC also took up once the analysis for OpenSSL after TrueCrypt, I believe, right? I'm not sure if...
Yeah, that is correct. Yeah, we did. That was like a few years ago. So NCC had done an analysis of OpenSSL.
Was that, were the findings made public? Because I never found any links to that audit report anywhere available.
I am not sure. I think a summary was then made public. I'm not sure whether, I can check on that if you want to afterwards with you.
And another quick question. In one of the slides you mentioned not enough randomness. So when you're analyzing source or any library for its use of randomness, do we assume that the constructions like say secure random are providing like true random data and we're just making sure that it's being used properly? Or are we also looking behind as to what's seeding the secure random and say, OS conditions and stuff like that? And I mean, do these form a part of the findings, or do we assume like basic primitives like secure randoms are working fine and then make sure that say rand is not being used and only secure random is being used? So I mean, do we peel the onion a layer further, or do we just assume the primitives are working fine and then base the audit findings on that?
Yeah, so and that depends. In a lot of cases, it will be you assume that secure random is working correctly. In some cases where you may need to have like more collaboration of like the hardware, look at from the actual hardware side of it. That's where you want to peel the onion to go further back and see is secure random being seeded correctly. But then that can then make it more and more complicated. So that at some point we need to say that the scope is that we're assuming secure random is going to be seeded correctly. We are going to have sufficient data, sufficient information as from our seed. And that can then become like a limitation or a constraint in terms of you need to ensure that that's true in your case.
So these axioms are like a part of the report where you state that, under these assumptions, these are the findings. Is
yes,
that,
yeah.
okay.
So you then describe it, assuming that this is like secure random, we assume that it's how you get, you seeded it correctly, for using that as an example. So, and you define exactly what's in scope there and what would be out of scope. Okay, thank you.
Robert, thank you. Let me check, I will say. It's finally, is copy is okay? That's,
yeah.
can put it.
All right.
It's okay?
All right. As he said, I'm Bob Relyea, and I work for Red Hat, and I'm the co-chair for PKCS 11. And that's all I'm going to say on that slide. So PKCS 11 version 3.2 is the next version of PKCS 11 coming. We've actually are full spec on 3.1. And the two main focuses of PKCS 11 3.2 are post-quantum and FIPS 140-3. And I'll go into those more detail later in the slides. We're also going to do a couple other things in this release. We're going to re-release the user guide. So we had a user guide. We referenced it in all of our versions of PKCS 11. We shipped it with the first version. But it didn't get shipped with each of the other versions. So people looking at 3.1 are confused, like, what is the user guide? And it hasn't been shipped since 2.4. So there's a lot of information in the user guide that's useful for implementing. So we're going to re-release it. Some other changes, we're going to do new async interface for long operations. We've added a mechanism to get a public key from a private key. We've added trust objects, which NSS has been using for a very long time as a private interface, and we've now moved this into the standard so other people can use it. TLS 1.2 master secret, we did not have a derived mechanism for that, and that's already deployed all over the world, so we need a mechanism for that. And we're going to have some new AED wrapping functions. Okay, so one of the main pieces that we're working on are post-quantum algorithms. Ever since PKCS 11 3.0, we now have a way of adding new interfaces to PKCS 11 that doesn't cause major disruption to people. So one of the things we decided was, rather than using existing ones to map the new post-quantum required semantics, we will create new ones that actually have names associated with that particular semantic. So we're going to create encapsulate and decapsulate key, even though we have functions that have almost exactly the same signature for derive and for unwrap. But these, you're doing key encapsulation. So the other one is a lot of the new post-quantum algorithms have data in the actual signature that's required in order to do the verification. That means we need the signature at a init time in order for those functions to work properly. So far, we have only created, whenever we had to implement one of these, we've only implemented them in the single shot form, where you do a single verify with a verify final that has the signature, so you can do all that in one shot. Now we have a verify signature init, and with that, the verify signature final. These all are roughly the equivalent to C verify and C verify final. And the expectation is, because existing algorithms can certainly support this interface, that if you support verify signature init, you would support it for all your algorithms, including RSA. Then moving on, the new post-quantum algorithms. All the post-quantum algorithms come in parameter sets. That is, they're distinct parameter sets, not definitions of how big a particular array is, et cetera, et cetera. So we've created a new CKA parameter set that would have identifiers for each of the different types of algorithms that would be part of your key. So this is a functionally equivalent of the ECC param mechanism, which basically points to a single curve. We're defining new chem mechanisms for ML-Chem. And then, of course, the parameter sets for ML-Chems tied to the key. So on signing, like chems, we're also using this mechanism. We have separate mechanisms for deterministic and non-deterministic signing. So the mechanisms themselves get kind of large. And there's also separate for the standard and the pre-hash. So the standard mechanisms would just do the built-in hash that's defined by the standard. And in the pre-hash versions would take a hash. In addition to the pre-hash versions that take the hash, we also will define sort of a la RSA SHA-256 or ECDSA SHA-256. We will also define versions with the combined hash so that the token can do the hash in the, on the token and then include it in the pre-hash. We have MLDSA and SHLDSA in the spec. We've actually dropped FMDSA. We were going to define FMDSA with parameter sets for the V3 version. And we decided, since we have everything else in the spec, that for now, if you want to do the pre-version for FMDSA, you would do that as your own vendor ID. So we won't have any V3 definitions in the current spec. Okay, on with FIPS version 3 changes that we have. The most important one is FIPS indicators. So these are done in a generic way. Instead of having a FIPS specific thing, we have general validation flags. So if your algorithm is able to do an operation, you can, that algorithm will set the validation flag if that algorithm meets the particular requirements and has been validated by that particular validation. Also, certain single-shot operations, which are difficult to see in the middle, these all create a new key. So we allow the keys to carry validation information. So there's a new authentication or new attribute called validation flags that will be on keys. And then those validation flags will be set if those keys were generated with validations, proper validation systems. This allows us to chain. So now when you do your next operation, if that flag is set on that key, and you do the next operation that is also validated, then the validation flags go on. But if the key is not set, then your validation flag wouldn't move on. So that you can do your operations and look at the end and say, this is all validated. So we do that in NSS actually right now, and you can check the entire SSL chain is validated simply by looking at the values of the end keys and ORing together. We have a new function called get session validation flags to be able to get those validation operations. So I've talked about validation flags. How do you know what flag meets what validation? Well, because there's only 32 bits, we didn't start defining a bit for every possible validation that could be out there. Instead, we created validation objects. So now you can query the token and get the validation objects. Anything that the validation requires you to report can be in those validation objects. So for instance, you can report the name that you put on the cert for that particular object, even if it doesn't match whatever name that you happen to ship your particular code with. So now you can get that stuff directly from software. You can include what kind of versions. So was this FIPS 2 or FIPS 3 validation? You can include things like level, some hardware validations. And then you can actually include then the flag that shows up in the FIPS indicator. So your FIPS 140-3 validation flag may be different than somebody else's, but you know that because you can query it from the validation object. And then applications can query for the validation objects they care about. Okay, async. Async is a new feature that we've added. The idea was generated because certain needs of HSS and XMSS. When you go to do a keygen on HSS, and if the keys that you're generating is big, or sort of a big enough set, it could take hours or days for that keygen to complete. And so how do you actually handle this? So we created a new flag called async session, which the application has to set to say that it understands async. And if the application sets it and the token wants to do an async operation, it simply returns CKF pending if it thinks that the operation is going to take a long time. That tells the application, okay, I've started, but it's not done yet. You can call async complete later on that session and get whether or not it's been completed. But of course, if it's going to take days, you probably aren't still running days later. So there's a function that's called getAsyncID that will provide enough information for you to then store somewhere. And then when your application restarts, you open async join onto a session, and now you can get the information. You can now call async complete on that session and get that this session is complete and get the status. Okay, trust objects. Trust objects are modeled after NSS objects that we, NSS trust objects that we already have within NSS. They're used to store trust values for certificates. So it gives you more than just trusted or not trusted. It actually gives you information about, is it trusted for these particular type of operations? Applications can store these trust objects. You do not actually have to have the cert itself. The trust object points to the cert with a hash of that cert itself so that you can tie a trust object directly to a specific cert. So all the base work is done on 3.0. I've allocated all the IDs, or mostly all the IDs, and the header file is almost updated. So right now we're in the review stage. Once we complete the review stage, we will go to committee draft. And our goal, I hope, is to get this done by the end of the year. Once we're at committee draft, you guys can go out and be pretty confident in being able to implement against these drafts. We had 0 changes between the committee draft and the final spec in 3.1. With the OASIS process, the final draft will probably happen sometime next year, hopefully. So, any questions? I'm running a little late. Yes, way back there. We got a mic coming back to you.
Yeah. Hello. Hi, it's John Gray from Entrust. I was just wondering, in the sign API for like MLDSA, they added a context. Is that being handled through the parameters? Because I didn't see anything mentioning that in your presentation.
Yes, there's an optional parameters for all the signing operations that allow you to supply the context. And if you do not supply that parameter, we assume a null context.
Okay, great.
The only exception is prehash has a parameter that's required, and that parameter has that context in it.
Okay, great, thanks.
Yeah.
Watson Lad, I'm a little unfamiliar with how it says once you have a chem decapsulated, you get a key handle. Is that going to put constraints on how you can deal with that key handle in hybrid constructions like we're seeing for TLS already?
No, it's what you get out of the algorithm is a key with a generic secret. So pretty much you have to send it to some chem at some point to turn it into a key for whatever you want.
Hey, Bob. Considering that PKCS11 is also used for small-scale devices like smart cards, and considering that FIPS 203 and 204 provides you some leniency regarding how to use these algorithms, I have two questions. The first one is, does the API that you specify and that you advertise here consider these leniencies, for example, that you provide the seed instead of the actual key for MLChem and MLDSA?
I don't remember having a seed. I don't think MLChem has any parameters right now in PKCS11.
Okay. Would that make sense? So that means you can, instead of the full key that is several kilobytes in size, you could simply provide the key or something like that?
So are you talking about the public key or the private key?
Private.
Okay, so the private key for the most part within the system is pretty much private, right?
Okay,
So you'd have to you get the private keys through unwraps. I would have to go back to see if, I don't think there's I'd have to go back to see, but I thought the seed was the only thing we needed in the key, and that everything else is generated from the seed.
Exactly.
Yeah, I think that's the way it's specified. Mm-hmm. I think the value is the seed.
Okay. And secondly, this is a similar kind of question, but this is a public value. There is a big matrix being created out of a key that can be or is allowed to be just pre-generated. And considering that it is a significant task always to regenerate that thing as part of an MLChem or MLDSA operation, is there a way that you can insert it instead of having the MLChem or MLDSA implementation regenerated every time?
So you mean in the public key?
Both.
In both. Oh, you mean from the seed?
From the key, actually, just from the key. You give the key.
Right.
The first step any operation does is first to generate this big matrix from it,
okay.
From the public part of the key, and then do whatever magic it needs to do.
We don't have anything specifically where you can specify that. That would have to, I would expect that be an implementation. They would generate it and store it and cache it if they wanted to do that, or you can cache it on the key. But no, we did not do anything in that way at that point.
Okay, thank you very much.
Yeah.
Hi, Jeff Anderson, Google. Actually, I think Watson might have asked my question a different way, but I'm a PKCS11 noob here, so sorry if this question is not well-formed, but for NCAPs, DCAPs, the key material which comes out of those, generally it's advised don't actually use it directly, like out of KDF with some domain separators. If you're doing a chem combiner, it's all written down how you need to do that. How opinionated would PKCS11 be about what those key diversifier derivation flows look like? Or are you really given the raw key and then it's really up to the operator to, it's like if you're doing hybrid, you run NCAPs twice and then do the KDF this way. the context for this is I'm trying to write a firmware blob, which I hope to be interoperable with PKCS 11, but I don't know how much to put in there.
So the keys that we generate currently, the way we have it specified is they're CKA secret keys coming out. So you couldn't send them directly to an encryption scheme, for instance, without running them through a KDF. Beyond that, we don't really put any requirements on it. So you could put it through almost any KDF you want. So if needed to do hybrid, you should be able to pass it into any of the PKCS 11 mixing functions that match that KDF that you have.
Awesome. Thank you very much.
I had a question about the async operations.
Yes.
So if you start a asynchronous key generation, let's say for a large LMS or HSS tree, did I understand correctly that if that generation process dies or the software just ends, that you can basically pick up where it left off and finish the generation at a later time?
You could implement it that way. The idea was you started the generation on a piece of hardware that's running,
Okay.
your process goes away, it's still running. You come back a day later and say, okay, here's the thing I'm connecting with, and is it done yet?
Got it. Okay.
So that's sort of the model. I mean, you could make that work in software by forking a process and having it continue on so that when your main process that kicked off
Right.
goes away, you can still come back and query that process.
Okay, but it's still, at the end of the day, it's still going to be a polling where, is it done yet? Is it done yet?
Yes, yeah.
Okay. Thank you.
So a quick follow-up to this last question. Is there any way of getting an estimate when it might be done so I don't keep coming back like, is it ready yet?
I wish there were. It's dependent on a bunch of us who are all volunteers taking the time to review the spec and in the middle of busy things like coming to conferences.
Yeah,
so that's the primary holdup on getting anything done. We have an editor who's very on top of it and who makes the changes very quickly. It's just a matter of everyone just finding time. Like, big chunk of it is, when am I going to have time to review all of these things I put in and make sure they're right in the spec?
I meant, like, is there like a correlation between parameter sets that might give an estimate of how long it might take?
He's talking about async.
The async.
How long an async operation? No, we did not put a mechanism in for that. No,
Okay.
Sorry. I thought you meant how long till the spec finished.
Hi, Rob. A question from the perspective of someone who implements hardware primitives in support of cryptography, whether it would be hashing a block of SHA-3 or doing NTT more efficiently. The question is in light of your presentation and the one that's coming up, OpenSSL. What are the different roles of what goes in OpenSSL and how it interacts with Red Hat implementations, what goes in Red Hat? So it's a very naive question, but important to me.
So my presentation is on the PKCS 11 interface, not in the Red Hat in general and how we use OpenSSL. OpenSSL has an engine that uses PKCS 11, and all this stuff is much lower level than the higher level thing. So the type of things you're talking about is even below the PKCS 11 layer. That's up to the PKCS 11 implementer, which primitives they use.
He's a user of your interface.
Yeah, to a certain extent. I mean, he also has his own, too. But yeah.
So this might be a naive question, I'm not sure, but so every time a new mechanism is added to PKCS 11, we see a version sort of upgrade. Is it possible to have like namespaces in the header file where, with extensions where, you know, a new mechanism can be added within a namespace and it allows for vendors to sort of add new stuff in without having to bump up the version?
So I'm the guy who's in charge in the namespace. So the way it works is when we add new algorithms, I allocate a namespace. We vote on it on the, in the committee. It becomes approved. And then when it becomes spec'd, it's locked in. I will change approved ones as needed. Now, what does it mean for you as a vendor? You want to add something new. Well, the two ways to do that is one, to come to the committee and say, I'm going to add this new thing. That's probably the best thing. It should be something that happens whether or not you do the second thing. The second thing is there's a reserved namespace called the vendor space, that any algorithm in that vendor space is vendor defined, and you are allowed to ignore it as a PKCS11 module, or you're allowed to interpret it any way you want. And typically what happens is the application and the vendor will use that private interface for the things until they become a spec. So like right now, NSS is using TLS 1.2, this new TLS 1.2 generation for the master secret. It wasn't specified in PKCS11. We're using a private NSS interface. Now that it's specified, it will have a number, and we will switch to the actual real number. I think that's about it for time. Oh, I got 3 minutes, but better to be ahead than not. Any other questions then? If it's quick? Okay.
Okay, so let's move on to the last presentation of this first session. In this time, we will see the OpenSSL roadmap. So let me introduce Neil Horman. He's software engineer of OpenSSL software services in the United States. Neil, please.
Thank you.
Thank you.
Good morning, everybody. I appreciate you all coming out today. There's more than I expected. I'm not at all nervous. Thank you. All right. I'm going to stand up here and say post-quantum until everybody thinks I know what I'm doing, and then we're going to go for lunch. No, we're not going to do that. What we are going to talk about today is OpenSSL's roadmap, what we're doing now, what we'd like to do, and how we're going to get there. What are we specifically going to do? I'm going to talk a little bit about who I am. I'm the new engineering manager at OpenSSL, so if you have a problem or you are angry with our software package, I'm the guy you're going to yell at, so it's probably a good idea to know who you're yelling at. Then we're going to talk about our current and future development processes, how we define what we're going to do, how we're going to track our work to get there, and what we do currently, what the difference is, and how we'd like to improve that. And then lastly, we're going to talk specifically about what our roadmap is, what we have on track for near-term development, mid-term development, and in the later future, with a few fun announcements. So, who am I? Generally speaking, nobody. But I am a software engineer. I have about 20 years of experience in the open source community, various and sundry ones. I've done low-level system work. I'm the IRQ balance owner. I own RNG tools. And have worked on those for a number of years. More recently, I have joined OpenSSL over the past year. One interesting thing to know about OpenSSL is that we value communication styles very strongly. As a largely remote organization, we generally feel like the ability to communicate clearly is critical to our ability to accomplish our mission. So in that vein, I am an owl dove. We use a personality communication profile tool called TIC. It's not unlike Myers-Briggs or something of that nature, but focuses more on communication styles. As an owl and a dove, I very much like lists and well-defined concrete tasks, and I like the harmonious work environment that stems from everybody knowing what they're doing. As it happens, I was asked to be the engineering manager at OpenSSL. Engineering management, turns out, is full of chaos and conflict. Who knew? I didn't. But here we are. This causes me a lot of consternation. It makes me nervous. But it has brought me to focus on making sure that we can bring a little bit of order to that chaos, which I'm hoping will be reflected in your visibility as a community towards how you use and interact with OpenSSL. So, without further ado, let's dive right in. How do we define our roadmap? The sad yet very honest truth is we don't. I wish we did, but it's a very fluid thing. That is, in fact, sort of a good thing, despite the fact that it doesn't always sit well with me. We have a lot of input from various communities, and therefore what we're working on from sprint to sprint or release to release can be a very fluid thing. It gives us the ability to be nimble and change priorities as they come in. It is, however, somewhat difficult. We address issues that come in as best we can with the resources we have available. Fun fact, there are 7 paid staff engineers at OpenSSL. If you have seen, thank you. If you have seen our issue list, there are more than 7 open issues. You do the math. That makes it hard for us because as issues come in, priorities shift very quickly, makes it very difficult for us to say, yes, this is what we want to accomplish moving forward. Doesn't leave us a lot of time for larger features that we'd like to integrate into OpenSSL no matter how badly we want. You know, next week a security issue is going to come in, that's got to take priority. So that's a challenge for us. As such, features are aspirational. We say we'd like to do this, and we're going to continue to say we'd like to do X, but we can never say we will do X, although we're trying to move in that direction. And then at release time, we look behind us and say, hey, I fixed 27 bugs and they're these, and we document that and say, look, release. And that's good. It moves us forward, but I think we can do better. I think we can give more value to you, the community, through various and sundry aspects to our process, give you a little more visibility and predictability in what we're doing. So yeah, that's our challenge. What's our process look like? Currently, it's this. Everything that we do happens on GitHub. Most of you, I hope, probably have seen it. We have a GitHub page, github.com/OpenSSL. It has an issue list. It is 400 pages long. We'll take a look at some stats in a minute. Yeah, it's demoralizing. But we're working on it. To that issue list, we have staff developers that open issues that say, this is something I'd like to work on, I think it's important. We also have you, community members, that say, this is important to me. Hey, you've got a typo in a man page. Hey, you've got a bug in this, X, Y, Z. All important. From that one massive issue list, we try to constantly, usually in a bi-weekly sprint type time frame, prioritize those issues. That's what goes through our refinement process where we say, this is important, we think it'll take this long, and then we create a work backlog, which is effectively that issue list. You may have seen it, we have a project board, it's visible. From that, we create pull requests, we go through a traditional open source review process, and we merge them. What's wrong with that? In some ways, nothing. It works, right? We have a list, we work on the list, stuff gets fixed, we move forward. In another, far more accurate way, no, that doesn't work at all. Inputs from the community and team members aren't really regulated. What do I mean by that? We don't really want to regulate who gets to open issues. You're all important, your issues are important, we want to see them. But it's very difficult to know from week to week what is the most important thing to work on. That means priorities are ever shifting. So what we thought was important last week may not be important next week. Or it may still be important, but there's something more important that's come along that means we have to shift gears. Again, there's no plan for larger efforts here. You know, it's very reactionary. This security issue came in, we really want to work on this, and we invested a week and a half in it. We really should finish it before we move on to the next thing. Oh, we can't finish DTLS 1.3 now. It's a problem. Equally importantly, perhaps more importantly, because of that reactionary nature, you, our user community, have no idea what we're working on. And somebody correct me if I'm wrong, I think that's probably infinitely frustrating to you. And I would like to fix that. So I mentioned I'm an owl dove and I like lists. I had fully intended this to be a slide deck full of bulleted lists that I would just read off and I would be perfectly happy. My management reminded me that not everybody likes that, so pictures. He did mention that, yeah, this would help drive home our point. So some statistics here that I gathered from our GitHub page. This is a recording of the last year's worth of work that we have done at OpenSSL, representing the issues that we have managed to close in purple with the issues that remain open in green stacked on top. This pattern repeats for almost as far back as you want to go. The important piece to take away here is that you can see we are creating an ever-growing pile of closed issues. That's great. You might notice that green is ever growing just a little bit wider as we move on. What this tells us is we have a slight gap in terms of how many issues we are closing versus how many issues we have opening. We always just have a few more issues getting opened, which is naturally a problem. It creates a growing backlog, and we're going to talk about how to address that in a minute. Where do they come from and where are they going? It was fun to make a Sankey chart. So in the last year, we had about 1,063 issues get open. About 93 of those came from our internal staff. These were aspirational, I want to work on this sort of thing type issues. Active community members, which I defined as people that opened more than 5 issues in this time frame, accounted for 145 open issues. And the general community, which is the remainder of, hey, you have a typo in this, or I have a bug with this application, accounted for the remaining 835, I think that's right, issues that got open. Insofar as dispositions go, we had approximately 840 get assigned to staff engineers or active community members, for which we are very thankful. Of those 840, approximately 692 came to some sort of positive resolution, either a change in the code, a determination that it was in fact not a bug, or needed, some sort of good resolution that solved the problem. With 148 winding up unhandled, abandoned, unable to get input from the reporter, what have you. Conversely, the community handled 223. These were individuals that were just so like-minded that took it upon themselves to help out. Again, super thankful. Of those, 157 got closed, with 66 getting abandoned for one reason or another. I think that's actually probably pretty typical of an open source project. I haven't checked, but anecdotally, I think that's about right. That represents to me an opportunity, though, to increase our community engagement, which I'm going to talk about in a little bit. A few more stats. Of those 1,063 issues, generated almost exactly 1,000 PRs, so code change sets, of which 435 are core staff members authored 435 of. I said that twice. Our active community members, again, those opening 5 issues or more, contributing 320, and the general community contributing 245. Again, super grateful for the community input. Would love to encourage more of that, and I'm going to talk about why in just a minute. So, what do we want to change? First things first, I want to clean up our issue list. Some of you may have seen this. Some of you may have decided to yell at me for this. I wouldn't blame you, but it is what it is. In that first set of stats, you saw that we have an ever-growing issue list with the delta being positive, which is not great. It also means that since that's gone on for a number of years, we have, as of the writing of this, 1,843 open issues, I think, some of which have been open for like 7 years. Tell me I'm wrong, but that seems not worthwhile. An issue list that long provides no visibility into what is truly important to work on. So, you may have seen blog posts about this. A lot of those issues have had the inactive tag added to them. They are just going away at the end of 3.4. Those who own them, if that was your pet issue, I apologize, but it's going away. I wish I could tell you something better, but if it's that important to you, make a comment on it. Let's take it out of there. But if not, yeah, we need visibility on this issue list so we can really identify what's important, and part of that is cleaning out the old stuff. Moving forward, we're going to have a new process for better planning. It's going to involve two large categories of things. Top-down planning, with a reserved amount of time for our staff engineers to focus on larger tasks. That's going to give us the ability to set larger direction for the project. Bottom-up acceptance of community issues. Those community issues, there's a lot of them, and they're in fact important. They're important to me. I know they're important to you. We're going to make sure that we find a balance of time for our staff engineers to work on both. More importantly, we're going to conduct some outreach to make sure that those community issues, which we do not have time for, are clear in their purpose so that you as a community can get involved to address them. And I'll talk about why that's important in a moment. Shameless plug, we're hiring. Anyone want a job? Please? No? Come find me after. And again, more encouragement of community contributions. One thing that I have learned in my time in open source is that a community lives and dies on its contributions. Not because it's contributions that make the project work, but because community contributions buy mind share from you. You get to set the project direction. I'm just a bus driver. I take you where you want to go, but I need you to tell me where that is. And the way you do that is by submitting code and participating in discussions. So that's really what I want to encourage today. How we do that, we have a new process. It's largely the old process with an extra filter. We have a planned issue board from which we take internally defined high-level tasks, and I'll show a bit of those that we'll be touching on in a few minutes. With the remaining time that we have allocated, we take community issues that we feel are important. That's what we publish on a project board, which you will get to see. That is the work backlog we'll be working on for a given release. That is, of course, then visible to you, which is really the key piece. So you can see for release X, this is what we're trying to get to. So yeah, I think I just recapped this. Project planning lets us consider larger features. Community issues still get considered. We just have to have a balance between there and larger issues. The project planning board that we'll have on GitHub gets published. You may have seen this for 3.4. We'll be publishing the 3.5 project plan shortly. You'll be able to see what it is. I should also mention releases are now time-based. We prioritize meeting a scheduled deadline above getting all the features in. So we try to gauge how much we can do in a given time frame, that being 6 months. So you get a release in October, you get a release in April. That is what we're moving towards. If a feature isn't necessarily ready, it gets dropped, we communicate that early. Community issues. This is what's left over. No amount of finagling of the project plan will address the fact that we have more issues than people. Again, we're hiring, but I could hire 200 engineers tomorrow and the problem would still exist. Again, this is something for you, not because I want free labor, although that'd be great, but I really want you, the community, to be involved. It is critical, not just because we need people to work on these bugs, but because I want your voice in the conversation about what OpenSSL should do next. It is your project. It's not ours, right? Like any open source project. It's something that you need to participate in so that we can make it better and address your needs going forward. So that's my call to action. Please get involved. I want to hear all your ideas. We all do. So, without further ado, what are we specifically working on? Some of you may have already read about this on our blog. We've had a project reorganization. This chart doesn't really do it justice because the projects aren't all under the corporation or foundation, but that's okay. We have a mission and values statement. It's available on our website for what you'd like to see. Generally speaking, we say all communities are important. It is critical for us to get input from you. It's everything I was just talking about. Underneath that, we have a corporation that focuses on our for-profit communities, our corporate communities, businesses, what have you. We have a foundation that focuses on open source communities. Underneath that, we work on all the same source code together. Additionally, we have the opportunity for other corporations to join our mission and values. This is largely a visual marketing aspect. lets you put your logo on the website. We can put your logo on our website. More importantly, it lets engineers talk to engineers. It gives us a shared resource pool to work with. We're able to help you with your projects. You can contribute to ours more easily. We can share CI resources, what have you. Come talk to me after if you'd like to learn more. Bouncy Castle and CryptLib have joined on. We're very thankful for that. If you are interested in doing so, we have lots of people here who would love to talk to you about it. Let's see, talked about the mission and values, mutual benefits from joining the mission and values, further community outreach. This is one more thing. This is something that's been bothering me. OpenSSL C project. Students coming out of university don't know C so much anymore. One thing we're trying to do is conduct outreach to various universities to get them involved as a community with OpenSSL in an effort to make sure that we have an ongoing community to help maintain it in the future. Obviously, as software develops, this is something we need. We're trying to take steps now to meet that. Specifics. OpenSSL 3.4 is in alpha right now with a release planned in October 14th specifically, I think. What have we been doing? DTLS 1.3, not going to make OpenSSL 3.4, but we've been working on the feature branch for it. We're hoping that lands in 3.5. I'll talk a little bit more about that in a minute. I should mention here also, look to the project plan online for specifics. This is just high level because, again, we have time-based releases. Certain items may get dropped for time. Shouldn't happen. It's an indicator that we've overcommitted. But as we get better at this, that shouldn't happen. DTLS is one thing we're looking at for 3.5, but we've been doing prep work in 3.4. Same with OCSP, OSCP, multi-stapling. That's something we've been doing prep work in 3.4 on. There's a feature branch for it. Performance improvements. I'm sure everybody that uses OpenSSL is somewhat familiar with this. The jump from 1.1 to 3.0 introduced a whole lot more flexibility, and performance issues, of course, came with that. This has been an ongoing focus for us. You can see increases in our performance metrics as you move from 3.0 to 3.1 up through 3.4. That is a continuing effort moving forward, for which we would love your input on. One of the difficulties with performance is that it is impacted by the multitude of use cases that you encounter. So what our performance measurements say may not meet what your use case is. If you have one, please get involved, open an issue, be willing to talk with us about it, have use cases or reproducers available so that we can address them. A Windows installer. Hooray, right? Anybody use Windows here? No? Don't worry about the Windows installer. Our goal is to have binary artifacts that are signed for Windows users. If you do have a Windows use case, it'll make your life a little easier. But that is available now if anybody wants to tinker with it. NSYS was a fun thing to learn. FIPS 140-2 update is complete for 3.08 and 3.09, and we are in flight on a FIPS 140-3 update for which indicators have been merged recently. That will be ongoing in 3.5, but we have the majority of the work done in 3.4. 3.5, again, one last word of note here. With time-based releases, each feature we require to be feature complete by alpha. If alpha is incumbent or is upon us and a feature is not complete, we drop it. We try to communicate that early. Our goal is to get good enough at planning such that this just doesn't happen. Sometimes it's unavoidable. For instance, with our DTLS 1.3 work, we have a community member that is contributing that, for which we are incredibly grateful. Of course, we don't manage their time, and sometimes that becomes, I don't want to say a problem, but they work on their own schedule, so sometimes things don't make features. We will be clear about that in our project communication. But our hope is to have that in 3.5. Similarly, Encrypted Client Hello is an aspirational community-led project that we're hoping to get in 3.5. We'll be clear about communication as to whether or not that happens. Quick Server, however, is something we are focused on. We're very pleased with the fact that we have been doing interop testing using the Quick Working Group's interop runner. Our Quick Client is passing almost all the tests now. We are very excited about that, and we are prepared to start adding Quick Server into that mix shortly. We have a feature branch. We fully expect it to hit 3.5. Let's see, FIPS 143 validation improvements. Sorry, this is an eye chart. Service indicators are done. We have FIPS 143 validation ongoing, and we'll be working with our new lab, Lightship, to get that complete. I should note we've elected to do a full BR1 submission with our FIPS 140-3 project. We opted not to go with an interim certificate because our primary use case for our validation is rebrands, and the interim certificate doesn't allow that. And because I can't have a presentation up here without saying post-quantum, post-quantum. We previously have stated post-quantum is on our roadmap, and that our timeline is eventually. I can say now we have onboarded Michael Bench, who was formerly with the OQS project, who is now leading our efforts to develop PQC. I've had a few chats with him, and we are working very rapidly on a plan to implement this. We don't have it set in stone yet, but our hope is that MLChem may land, don't quote me on this yet, but this is our hope, that MLChem will land in 3.5 with further updates and algorithms to be available in future releases 4.0 and forward. But stay tuned to our blog and our project updates, and we'll have that documented for you. And 4.0, lastly, this is still in early planning. We don't have anything written down for it yet. We're also still in discussions as to whether or not a 3.6 release is necessary for those who might want it. I should note 3.5 is anticipated to be an LTS release for anybody concerned about that. But we're talking about 3.6 versus 4.0. I'm sort of leaning towards 4.0, but input is appreciated. You can expect with any major release that there will be some ABI changes. It will be far less invasive than the move from 1.1 to 3.0. So don't hit the panic button. But you can expect some changes. One thing we do know about is that we're planning on removing at exit. For anybody familiar with the automated cleanup of the library, that has produced no end of consternation for many people. And our intent is to remove it and require manual cleanup from your application. It will provide some potential false positives for any memory sanitization checking. That is a manageable thing. We can all, of course, talk about that. There'll be some other things. We're talking about deprecation of TLS 1.0 and 1.1 above and beyond our already established deprecations. Plans TBD. But let me know what you're interested in. We are in the early planning stages, and this is your opportunity to get involved. You should. I really want to hear what you think, because knowing that and getting you involved makes us all better. Hey, we're done. Who's got questions? Oh, a question already.
Hi. I work at Akamai.
Okay.
I work with Rich and Ben.
Okay.
For years, we have, along with people at OpenSSH, along with people at Node, complained that OpenSSL is not playing well with others. If you want to use AES GCM right now in OpenSSL, you need to use an API that's specific to the provider interface to set the tags. Other implementations, like Boring SSL, don't do this. OpenBSD has a highly secure, high-level application interface that 99% of users should be using to connect to a server securely. OpenSSL doesn't. These things are not being talked about. Instead, you're building a quick API that nobody wants. This Chem API, is it going to continue the problem? Are we going to force the entire acquis of software that exists and maintained outside of either of our organizations to pick which implementation to use with the consequent bad effects on the net, on everyone picking? Is that going to continue? You know, where's the commitment to play nice with the community and with developers so that we don't have another Heartbleed? And if we do, we can get rid of the implementation that caused the problem.
Can you condense that down into a question?
Yeah, why should we believe that you're going to listen to us now when you haven't for 6 years?
So, I hear the anger in your voice. I can understand that. What I can't say is that I'm privy to that conversation. I've been here a year. I know I've had conversations with Rich before, and they all sort of fall into this line, right? Why haven't I done this before? The best answer I can give you is I don't know. And I mean that honestly, right? I don't know, because I don't know how those conversations went.
Are these things that you're considering reprioritizing so that people at OpenSSH, for instance, can integrate AES-GCM in a way that works for them, can integrate MLChem in a way that's going to work across implementations of the OpenSSL API?
I mean, the happy, shiny answer is yes, absolutely. But the honest answer is I don't know until I have that conversation with you. I think the best thing I can tell you is, and I'm sorry to say this, you're just going to have to try. And I want to say that, yes, we're absolutely going to do that. I can't promise everything's going to be perfect, but I can tell you that's where I want to get to.
Okay, let's have that conversation.
Yeah, that's fun. Absolutely. Oh, there's a line. What do you got?
I'm not going to yell.
That's okay. I'm getting used to it. It's all right.
Yeah. Quick question about the post-quantum stuff.
Yeah?
You said 3.5 might have MLChem.
Maybe.
Is that a statement about FIPS as well, or just it's in there?
Are you asking, is MLChem going to be FIPS validated in 3.5? Negative, Ghost Rider.
Yeah.
No, it's currently our FIPS 140-3 validation is against 3.1.2. I do not anticipate that MLChem will be backported beyond 3.5 where it's introduced.
Okay.
I'd love to say otherwise, but I think the reality of the situation is as such.
Yeah. So the OQS type work, provider style, it might be independent of having any post-quantum stuff? Or
Not sure I understand the question.
so the focus seemed to be on the provider work that was done in OQS. But the underlying actual crypto algorithm doesn't include that. So it seemed like a disconnect to me.
There is a disconnect there, and it's something we're working on. This announcement, I should say, we managed to put this together on Monday, so it is fairly nascent. I can only ask you, please stay tuned. We are figuring that out. But again, this is the sort of conversation that we'd like to have to make sure everybody's included and that we're addressing all the needs of the community. Hi.
Hi, this is as a follow-on to, I guess, the last question, and that is, what are your plans for FIPS 140 and your next FIPS 140-3? I know your current project is on, is it 3.1.2, and
that's my recollection.
Are you targeting a 3.4 or 3.5 release or something with PQ in it? Do you have any timeline?
As long as there's no follow-up question, sure. The honest answer is I want to say yes, but we have not made that decision. Our goal is to arrive at a cadence where we are doing a few validation or revalidations a year. We have not arrived at a point where I can commit to that yet.
Would it be okay if vendors take on that? Like if a vendor decided to take, say, a 3.5 release probably and put that through a validation, do you think that it would be?
You mean if they wanted to independently validate FIPS against a version of OpenSSL of their own accord?
Yeah.
Yeah, 100%. Go nuts. We have that happen all the time.
Okay.
Please do. It'd actually be very helpful. I know KeyPair has done exactly that, in fact, and I know of a few other companies that have. Yeah. Hi.
So when MLChem comes into OpenSSL, two things. Where would the code sit, in which part of the tree? Will it sit in the crypto subdirectory elsewhere? And two, where will it be surfaced? Will the user community be expected to go through EVP interface or some other place, etc.?
I think a lot of that is probably TBD. The architecture is still pending. I think you can expect it to use our regular APIs, but I will not commit to that yet because we have just started talking about it.
So the question is from the perspective of an application programmer writing a C program trying to access an OpenSSL function.
Right.
So what would be your, I should say, guiding principle? Because you have been advocating that we go through EVP, and a lot of code sits out there which is buried underneath. So your current thinking won't hold you accountable as to how we should reason about it, both as a user, which API, and as a contributor, which part of the source code tree?
It's a fair question. I'll admit to you right now, PQC is a lovely set of letters to me, and beyond that,
Okay.
I do know a little bit about it, not a lot. I think the guiding principle is supposed to be, or should be, that we use the existing APIs to manage it like we would with any other algorithm. As to whether or not the fit is appropriate there is a discussion that has yet to be had.
Last but not the least, Kapil's question, Kapil walked away. The NCC Group's audit report.
Fantastic. Thank you.
Is it available or?
I don't know. I'd have to look that up and get back to you. I apologize. Oh, even more. Okay.
Well, I was going to try to answer his question.
Oh, yeah, go ahead.
Because I'm not looking for a job, but
You can.
just because I had a little bit of experience with the OQS provider work, and it does use the EVP interface, and I assume that's what Michael's going to do, who's taking that
That's
on.
true. OQS does, so there's some precedent for it. I didn't think of that. Thank you. Everybody, thank you for coming. We're done.